The temperature of matter is a direct measure of the motion of the molecules. The greater the motion, the higher the temperature. When studying the flow of energy during a chemical reaction, we need to distinguish between the system and the surroundings. The system is the small, clearly defined part of the universe that's actually being studied. The surroundings are made up of the universe and even the container in which the reaction is taking place. To clarify, the mixture of chemical substances that undergoes a reaction is always the system, and the flow of heat can be from the system to the surroundings or vice versa. All matter has unique properties that distinguish it from other matter. There are extensive properties, which are properties that change when the size of the sample changes. Then there are intensive properties, which do not change when you take away some of the matter. One of the extensive properties of matter is called heat capacity. Heat capacity is a measure of the amount of heat energy that's required to change the temperature of a pure substance by a given amount. In chemistry, it is the amount of energy that's required to raise or lower a system's temperature by 1 degree Celsius or by 1 Kelvin. When an object is heated, its temperature may rise rapidly, which indicates that it has a low heat capacity. If the object's temperature rises slowly, then it has a high heat capacity. Generally, metals have a very low heat capacity, and it doesn't take long for them to get hot, and that's why you need hand protection when cooking with heat in the kitchen. Heat capacity is represented by the variable C. It is equal to the heat energy supplied to an object, which is Q, divided by its change in temperature, delta T. An object's heat capacity depends on the amount of the object exposed to the heat energy. For example, water has a specific heat of about 4.184 joules per gram degree Celsius. So you can interpret it as when 1 gram of water takes in 4.184 joules of heat energy, its temperature will raise by 1 degree Celsius. With this understanding, it isn't difficult to understand that 1 drop of water is going to heat up much faster than a whole swimming pool of water. So we could correctly identify that the swimming pool has a much higher heat capacity than the water droplet, even though both of them are made up of water. Other terms related to heat capacity that you should be aware of include specific heat capacity. For this term, it doesn't make a difference of how much of a substance you have, therefore it's an intensive property. Its formula definition is the heat capacity divided by the mass of the substance. The units are joules per kilogram Kelvin. Another intensive property is the molar heat capacity, which is defined as the heat capacity divided by the molar amount of the substance. The units are joules per mole Kelvin.